Hello, I'm Brian Corbridge, and this is my PowerPoint discussing the fourth lab about oscillations and spring force and different types of energies. So the setup for this lab is pretty simple. Uh, there's a 4/10 of a kilogram mass hanging from a rope attached to a spring, and we drop this with there's an offset in the y-axis and the x-axis, so we expect some movement coming from this mass. And we really want to study spring force, tension force, which is not as relevant to this, but still applies. Gravitational force, because gravity's always acting on it. Potential energy, kinetic energy, spring energy, those are the main ones. We're trying to the purpose of this is to kind of predict how the mass is going to be moving through our code in GlowScript, which we'll get to in a bit. So you can see here, this is the right here. This is the video we're going to be analyzing. The initial conditions are, like I said earlier, well, to be more precise, it's 0.402 kilograms at the initial position, which is around about right here, which is negative 0.134 as the x coordinate and negative 0.697 as the y coordinate. We're not really worrying about the z coordinate. And we have the origin at where it is hanging from, the attachment point to this stable structure right here, which is not moving. Um, the object is starting at rest and we drop it. The relaxed length of the spring is 0.123 meters, and the spring constant is 6.83, which we'll use in our code. So here's all my relevant code for this portion where we try to predict and graph how the mass will be moving from the video we analyzed. Um, like I said, here are the initial conditions, the mass, the position, the velocity starting at rest, so that's 0. Gravity constant 9.8, spring constant, relaxed length. Here's what we need to set up, the spring force equation and whatnot. Here is what we need for the energies, kinetic, potential, change in energy, total energy. Yeah, we just plug in what we have from the known formulas into this code. Um, yeah, and here again, initial just kind of stated the obvious right there. Force of gravity, which is constant, so we have that as this vector. Spring force F net, which is gonna be because there's only two forces acting on it, which is the spring and gravity, so that will be F net. Here we have, velocity kind of derived from the velocity update equation. And same thing with the position, derived from the position update equation. Here, is the update for the spring. We have the ball position for L. L hat's L divided by the magnitude of L. You know, the pretty basic stuff here derived from our known formulas that we've learned throughout the course. Um, and then here are our energies and change in energy. So here's the kinetic energy. Here is the delta delta kinetic energy. Um, potential, uh, delta potential, and spring energy, and total energy, and change in energy. Yeah, it's pretty basic stuff here from what we've learned. Here's all that code graphed out compared to what our results were from the tracker, which comes up here, not so much here. But if we dive into it, the blue is the change of kinetic energy. The red is change of potential energy. I don't know why this kind of goofy, like around here and here. There's some error in my code. I was not able to pinpoint exactly where that was, but nonetheless, change in spring energy, yeah, because you see it's constantly retracting and uh, expanding and retracting. So there's going to be that change in spring energy, and uh, change in energy should be the total energy should be constant because, as you can see, the kinetic and the potential should be kind of on opposite sides of, well, on opposite wavelengths, I should say. And then, yeah, here we have, this is another error in my code. I don't know why the Y position isn't really changing much, but I was pretty accurate with the X position. Um, and if we were to, start with initial velocities, that would change it, but we didn't. So